Welcome to Smalltalk Daily for Thursday, September 18, 2008. This morning I'd like to go through something about basic Smalltalk that I really haven't covered in detail before, and that's the BlockClosure object. So block closures are defined by putting braces around things. Now typically you find these used to implement various pieces of the library, like the do method. So do, I have a collection here I've defined as an array of numbers, 1, 2, 3, and 4. And here I'm just iterating across them. So for each one in it, print them to the transcript and then put a carriage return. So I execute this code, and there it is. Now that's not terribly exciting, but the interesting thing is if I go ahead and I browse the implementers of do colon, and I go ahead and I look at do colon in collection, and I see that that's just specifically done in each one of these. So let's pick one of them, like say list. And it goes through and it implements 1 to limit do. And if I look at the implementations across some of the other collections, I'd be able to see how do is actually implemented. But in any case, let's just drop that for the moment and go and take a look at something more interesting about blocks. So let's go in here and we'll define a basic block. So block colon equal, and I'll put a block down, transcript, show, and quote, hello there. So here I've defined this. Now watch what happens if I just go ahead and execute that. You didn't see anything visible happen. If I go ahead and I inspect block, you'll see that it is an instance of a closure. So if I go ahead here and send value to it, you'll see that what happens is it executed. And that's the nice thing about a block. A block is an anonymous function, and I can send value to it at any time and execute it. But it goes a little beyond that. Let's go ahead and write a more complicated block, block 2 colon equal, and this one we'll send in an argument for. So we'll say transcript show val print string. We'll make sure that whatever I send can be printed as a string and put out a CR after that. So let's do that one. And again, when I do this do it, nothing happens. But now let's do this. Block 2 value colon 3. So I should get a 3 up in the transcript, and sure enough I did. So you see what's going on here. I can describe anonymous functions that either take input or not and execute them arbitrarily. Now they're full objects, which means I can pass them as arguments. I can store them out to disk. I can even pass them across the wire to other running Smalltalk images somewhere else. Of course, if I do that, I'd have to make sure that any classes that get mentioned in the block here on this side are defined in the remote block. But with those limitations, I have an object that I can do anything I want with that has execution capability. So ponder that for a little bit. And that's pretty much all I wanted to cover today. Until next time, have fun with Smalltalk.